Hello. Welcome back to the next video of complex numbers. All right, let's get started. So now in this video, we are going to do what is absolute value of a complex number. Absolute value of a complex number. Now, absolute value, it has another name, which is called modulus. So absolute value or modulus of a complex number. Okay. So what is this absolute value? Let's say you have a complex number, a plus bi, okay? And we have to find out the absolute value or modulus of this complex number. So first of all, it is denoted by these two straight lines, a straight lines. You might have also done this concept with the case of real numbers, right? Like what is the absolute value of 3. So we used to draw these two straight lines and that's nothing but 3. What is the absolute value of -8? That's nothing but 8, right? So those similar straight lines we are going to draw here. Okay. So I'm going to explain you. So if you remember, your absolute value of real numbers, in case of real numbers, if you remember its geometrical interpretation, it was nothing but the distance of whatever is inside these two straight lines. So distance of 3 from 0, right? So distance, we always used to get a positive number because distance is just positive. And if you find out what is the absolute value of -3, so again, distance of -3 from 0, that's again going to be 3, right? So that was the geometrical interpretation in case of absolute value of real numbers. Similarly, first we will understand the geometrical interpretation in case of complex numbers. So absolute value of a complex number is nothing but its distance from the origin, right? And now we don't say 0, we say origin because now we are in 2 dimensions. So in 2 dimensions, 0 becomes origin. So in real numbers, the distance in real numbers, the absolute value of any number was its distance from 0. And in case of complex numbers, absolute value of a complex number is its distance from the origin. Let's understand how we will find out this distance. So I'm going to change the background to the graphical background. And let's just quickly draw the x-axis and y-axis. I mean, real and imaginary axis. Okay, so we have this. Okay, now let's say this is our point. This is our complex number, a plus bi, right? This green dot. So what does this mean? This means this point has coordinates a comma b, correct? So this also means that now see this point has coordinates a comma b. And as I said, absolute value of a complex number is its distance from the origin. That means we are interested in finding out this distance, right? This will be its distance from the origin. We are interested in finding out this. So just pause the video and try to think, how can you find out this particular distance? Just pause the video. Okay, I hope you did that. Now let's see. What we will do is we'll do a little bit of construction over here. I will complete this triangle. I will complete this right triangle over here. Okay. Now, if you see, we know what is this distance. I mean, we know what is the length of, see now this is a right triangle. This is what? This is the hypotenuse. This dotted line is the hypotenuse, what we want to find out. And then the other two sides are the legs of the right triangle. And if you look at it carefully, this distance is nothing but A. From here to here, this is A. And then this distance is nothing but your B, right? And now if you remember the Pythagoras theorem, if you want to find out the length of the hypotenuse, so what is this? This is nothing but the square root of sum of squares of the other two legs. So this is square root of a square plus b square, and that's it. So your absolute value of a complex number is given by square root of a square plus b square. Let's do an example. I'm going to change the background to the normal background now. All right. So let's say that we have a complex number -2 plus 10i. Okay. And we want to find out what will be the absolute value of this complex number. So it's very simple. First of all, this is what we want to find out. First of all, identify what are the values of A and B. Let's change the color. So A here is -2 and B here is 10, right? Okay. So your absolute value is going to be square root of A square plus B square. That means square of -2 plus square of 10. So this is 4 plus 10 square is 100. So you get square root of 104. Now we will see if we can simplify this. So let's see. 104. This is 2, 5, and 2, and 26, and 2, and 13. Okay, so this can be written as 2 times 2 times 2 times 13. So out of these two 2's, I'll take out 1 2 outside, and I'm left with 2 times 13 in the square root. So this is 2 times square root of 26. So this is the absolute value of -2 plus 10i. This is nothing. This 2 times square root of 26 is the distance. It's going to be this distance. Let's do one more problem. Okay, just I'm going to ask you a question. Is 8 a complex number? Pause the video and tell me if you remember the concepts of algebra 2 clearly. Pause the video and tell me, is 8 a complex number? Okay, if you said that 8 is not a complex number, then you were wrong. 8 is also a complex number. How? I can write 8 as 8 plus 0 times I. I can do that, right? I have not changed it. I have just added a 0 because 0 times iota is 0. So I've just added a 0, which means I haven't changed the value of it. So every real number, see, 8 is actually a real number, but every real number is also a complex number. The only difference is that its imaginary part is 0, right? This 8 is also a complex number. I can write 8 as 8 plus 0i. It's just that its real part, we have its real part. Now see, if I say that z is 8, so real part of z is 8 and imaginary part of z is 0. So every real number is a complex number. Now let's say if you want to find out the absolute value of this. So it's just gonna be 8. How you can, so see, this is A, this is B. So you will do 8 square plus 0 square. So that's 64 plus 0. So 64, and that's nothing but 8. Okay. Let's take one more quick example. Okay, all right. What I really want you guys to do is whenever I'm doing a problem, just pause the video and try to solve the problem on your own and then play the video again and then see the solution. All right, so this is your complex number 10 minus 10i, and we want to find out the absolute value of z. Okay, so we know that absolute value of any complex number is given by this. What are the values of a and b? Here, a is 10 and b is negative 10. So let's just plug in these values in the formula. Okay, so 10 squared plus value of b is negative 10. 10 square is 100. Negative 10 square is also 100. That is 200. And let's just find out the factors. So 2 times 100, 2 times 50, 2 times 25, 5 times 5. Okay, so this can be written as 2 times 2 times 2 times 5 times 5. So I can take out 1 2 and 1 5 outside. And 1 2 is left inside the radical. So this becomes 10 times root 2. So this is the absolute value of 10 minus 10i. So this is how we find out the absolute values of a complex number.